NASA released some stunning new imagery and video of Perseverance's recent landing on Mars. I'll show that in a minute, but first I wanted to talk briefly on where Perseverance landed and why NASA picked the location that it did. First, here's a map of where the various landers and rovers have landed on Mars over the years. This is what Perseverance's landing location looks like from Earth through an 8-inch Celestron SCT telescope. I took this imagery back on October 10, 2020, from my backyard in Tulsa, Oklahoma. Looking at a high-resolution map, you can get a better idea of the landing location. Jezero crater, where Perseverance landed, is on the edge of a higher elevation region of Mars and a larger crater with much lower elevation. This crater is interesting because it appears that water flowed through the crater in the past. High-resolution imagery from the Mars Reconnaissance Orbiter shows what appears to be a delta within the crater at the end of a river channel. A 3D model of the site shows this a little better, and it is easier to visualize water flowing down the channel and through the delta region and into what would have been a water-filled crater. This green line shows one potential path for the Perseverance rover to take up onto the delta, across a major channel in the delta, and up the former river channel and onto the crater rim. Perseverance will be taking samples of the regolith all along its path to eventually be returned to Earth by a later mission. It will also do extensive testing of the samples along its path and send that analysis data back to Earth. The Perseverance landing, which I will play here in a minute, seems overly complicated because Mars is a challenging planet to land on. The atmosphere is dense enough to require a heat shield on atmospheric entry, but not dense enough to allow a rover of this size and weight to touch down gently using only a parachute. While the parachute used on this mission slowed the craft considerably, Perseverance would have still crash-landed without another means of slowing down. So a powered descent vehicle was also used to provide a gentle landing. It would be possible to use a powered descent vehicle all the way to the surface instead of using a parachute, but that would require a lot more fuel and thus a larger descent vehicle, and that in turn would have required a much more powerful rocket to launch the spacecraft from Earth. After the parachute was released, the powered descent vehicle then lowered Perseverance to the ground with cables before detaching the cables and flying off away from the rover. The powered descent vehicle lowered the rover from above instead of flying underneath it, since if the craft landed with the rover on top, there would be some chance the rover will get stuck in some way trying to get off the vehicle, and that would pretty much ruin the entire mission. Anyway, here is the amazing video NASA released showing the landing from the point of view of the rover and the powered descent vehicle.
Applicant indicates chute deployed.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Finally, here is the first panoramic image created from Perseverance's cameras. I'll have a link below in the description to where you can view the thousands of raw images that have already been transmitted from the rover's various cameras. Anyway, that's all for now, and thanks for watching. Bye.